So let's remind ourselves of what we need to do when drawing a good line of best fit and what not to do. Okay, so the number one thing, and really this is the whole idea here, is we need one straight line that needs to represent the trend in the data, right? We need one straight line, A, because that averages out all our data and gives us the overall trend, but B, because we need one straight line to be able to calculate the slope of it, right? A common student mistake, this is more common in physics 20, by physics 30, most students have stopped doing this, but a common one is to just connect the dots, right? Do you see why that's no good? Like, what if we change? Like, what's the slope of this line if we need the slope? What's the area underneath this if we need the area, right? So we definitely do not just connect the dots, right? That's also, this doesn't tell me anything about how y depends on x, right? It's all different in different places. I can't get an idea of how y depends on x from this line because it's not a line, it's multiple different lines. Is it really true that y depends on x in a different way when x is these numbers versus when x is these numbers? That's what we're suggesting with something like this. So we don't want to do that, okay? That is not good. We want, more than anything, okay, the first step with this is step back, look at the data points, okay, and try this now. Just visualize the line that is suggested by this data, right? We can see that, okay, as x is increasing, it looks like y is increasing as well, right? And can you kind of see, visualize the line that represents this trend, right? So something like, I mean, this isn't going to be perfect. I'm just doing it freehand, okay? But we want it to represent the trend in the data. So maybe something like that, okay? Probably could have done better, but it's pretty solid, right? Maybe I could actually have shifted it up a little bit just because there's 3 points up there. Now I've got 3 points above, 3 points below. That looks pretty good. But do you see what I mean, right? That line is just representing the trend that our data suggests, right? Okay, that is the number one goal. First things first, that is what we're trying to do. Draw the line that represents what the data is suggesting in terms of how y depends on x. Now there's a couple kind of checks we can use, but again, this is really what we're doing. These are just kind of tools we can use to check if we've done a good job or not, right? One of the checks we use is that there should be roughly as many points above the line as there are below the line, right? Now we got to be careful because sometimes students get obsessed with that and they'll say to me, okay, I drew my line of best fit, right? And they'll say, it's good because there's 3 points above the line and there's 3 points below the line. Well, true, but does this line look like what the data was suggesting, right? It's way off, right? It says that as x increases, y is decreasing, but that's not what our actual data points from our experiment suggested at all, right? So we don't want to do that. It's not the be-all, end-all. Sometimes students get a little too obsessed with this one and they forget the big idea. We want it to represent the trend in the data. Another big common student mistake with lines of best fit is trying to force it through certain points. Students really feel sometimes like every line of best fit should go through the origin. They feel like it needs to go through 0, 0. There's a lot of situations where when x is 0, y isn't 0. In fact, looking at this data here, right, does it look like it should be headed to the origin? If we try to force our line of best fit through the origin, okay, even if I try to do the best I can with it, it's not great, is it? Right? Like compare that red one to that green one there, right? This is what happens when I force it through a point that I think it should go through, right? But there's no reason that data did not suggest that it was projected back to the origin here, right? Compare how this represents the trend in the data to this one. Doesn't this look a lot closer, right? This looks a lot more close to what our data points individually were suggesting. Okay, one kind of way we can think about it, I like this as a way to basically check your work, right? Have you minimized the average distance of a data point from the line? Meaning like overall, have you made it so that the points are as overall, on average, as close to the line as they could be, right? One way to think about it is that if you were to take a red pen and you were just to connect every point to your line, have you kind of minimized the amount of ink you would have to use, right? We did an okay job with the green one there, right? Like this though, oh boy, most of my points are actually really far away from my line, right? This one, you can see now, oh yeah, look. These data points are really not being super well represented by that line of best fit. Okay, so you must use a ruler, right? Don't even think about not using a ruler. More than anything, you're trying to represent the trend in the data. So step back, look at the data points, visualize the line that represents that trend. Okay, and my tip too, always do it softly in pencil at first. I've been doing lines of best fits for a long time, right? I'm a physics teacher. Even I often don't get it on the first try. I'll draw in my line of best fit, I'll step back and look at it and I'll realize, it's a little bit off. It needs to be shifted a bit this way or that way. Honestly, it's pretty rare to nail it on the first try. So draw it lightly on your first go, and that way you can easily erase if you need to, because I'll be honest, you probably will need to once or twice, right, until you get it to where you're happy with it. But with that in mind, with those kind of principles in mind, let's see if we can draw a line of best fit for this so that we can actually start doing some graphical analysis, okay? So step back, visualize the line here, okay? Visualize the line suggested by this data, and then we'll pull out our rulers. I'll pull out my ruler, and I'm gonna try to draw the line that represents what these data points should suggest. All right, so here's what I came up with after pulling out my ruler and trying to draw the trend line, the line of best fit, okay? It took me a couple tries, even just now, I'll be honest, right? So don't feel bad if you're not like perfectly happy with it on the first try. It can take a couple to get it to where you think it looks about right. So we can go through our checks here, right? I've got 2 points below, and I've got, 2 points above, a couple that are right on the line. I think it looks pretty reasonable. Now, when finding the slope of a line like this, right, don't make your life harder than it has to be if you can avoid it. What we want to look for are nice, easy to read points. And I mean by that, points where we don't have to estimate, right? Like I wouldn't really want to use this point here because like, where is that? Is it at like 1.83 or like 1.84? It's a little tough to say, right? It's much easier if we can find points that are directly on the intersection of some grid lines. Like, look at that one. That one jumps out to me. That's a very good point, right? I don't have to estimate. I know that it's here on the x-axis and it's here on the y-axis. So let's use that as one of our points, definitely. Okay, that's a good one. Let's look for another one here. How about, actually, maybe up here? That's pretty good. That looks like it's just about right on that intersection. So I'm going to use those 2 points on the best fit line. Again, I am not going to use the data points. Otherwise, I'm not using all of my data. I'm just using those 2 trials, right? What was the point of doing the whole experiment then? Okay, so now we just need to get the rise and the run for those 2 points. So